Welcome students to today's lesson. We are still continuing with regression, and this will mark the end of our regression practices. And we have a given set of data here as an example. So the following data regarding the heights in symbol Y and weights in abbreviation of X of 100 college students are given. So we extract this data from a table which has been constructed, and the sum of the weights, the heights, the sum of the weights, that is X, is 15,000, and the number of students who are there are 100, so N is 100, and the sum of the product of X and Y, that's the product of height and weight, is 10, 222, 250, and the sum of the heights is 6,800, and the sum of weight squared is 22,500, and the sum of this is height squared is 46,30,25. So therefore, we've been given these sets of data from the statistical data analysis table. So we just want to use the given data to establish the regression of this particular data. So to do that, we are going to use this formula whereby R is the regression given by the sum of the product of X, Y divided by the number of sample N minus the mean coefficient of regression of Y of X bar times that of Y bar. We are dividing by the deviation in X times that deviation in Y. So all these parameters I have discussed before in the previous videos. So whatever we've not discussed is the deviation in X and deviation in Y. How do we calculate them? So the deviation in X is computed by taking the square root of the sum of X squared divided by N, which is the total number of sample, minus summation of X divided by N, then we square. Remember, the square is outside the bracket. This one we are squaring the X. And to calculate dy, we take the square root of the sum of y squared divided by n minus the sum of y divided by n, then we square that result. So therefore, to calculate the dx, the sum of x squared is 22,500 divided by n, which is 100, minus the sum of x is 15,000 divided by 100, then we square. And we find the square root. If we do that, we get 15. Therefore, the deviation in y is computed by the sum of y squared, which is 46,30,25 divided by 100, minus the sum of y, which is 6,800 divided by 100. Then we square that and we get the square root and we find 2.5. Then to calculate the x bar, or the mean in the x data set, we get it by the sum of the x divided by the total number of the sample, which is 100. That gives us 150. And y bar is the sum of y divided by n, which is 6,800 divided by 100, give us 68. Then we have all the parameters which are needed to solve for r in this given formula, and therefore we just need to key in the figures. The sum of xy is 10, 22, 250, and n is 100 minus x bar is 150 times y bar, which is 68. We divide everything by the deviation in y is 15 times that of x is is 2.5. So if we multiply and solve these particular figures, we get 0.6. And 0.6 is less than 1. So this means that we have strong positive regression. Students, this marks the end of our today's lesson. I encourage you to continue practicing and don't hesitate to reach me through my contacts.